Next speaker is Liz Ashby from the Biodiversity Council, and Liz is joining us by telephone. Liz, over to you.
I'm the Policy and Innovation Lead at the Biodiversity Council. I wanted to focus on the invasive native species element. Redbank is expecting to source a significant amount of biomass from invasive native species. Invasive native species are native woody plants that regenerate after disturbance or grow in areas where they didn't previously occur. The intent is to clear those species that have reached unnatural densities and dominate an area to achieve better land management goals. Clearing of invasive native species can be done without formal assessment or approval under the Native Veg Code by local land services. So it's not subject to significant amount of scrutiny. Clearing of invasive native species in 2023, which is the last reporting period, made up the largest component of authorised clearing in New South Wales at 65%. But the assessment report for the first stage of Redbank states that they require 500,000 dry tonnes of biomass from invasive native species. And Redbank's own study says 25 tonnes of biomass are sourced per hectare. That would necessitate clearing of 20,000 hectares. So in 2023, when invasive native species made up the largest component of authorised clearing in New South Wales at 65%, it was still only 6,219 hectares of clearing. So the clearing of invasive native species will need to increase by at least 3 times to provide enough biomass to reach their goal of 500,000 dry tonnes of biomass. And the area cleared is likely to be much greater than 3 times, because that assumes that all invasive native species cleared would end up being burnt, which is unlikely given issues related to logistics of getting that material from different properties to the power station. As I said before, there's insufficient oversight to ensure the system is not abused. And there is a precedent for waste products from land management leading to more harvesting of a natural resource. This may seem unrelated, but it actually talks to the incentives that you provide in the system by providing profit for a waste product. So Victoria's kangaroo pet food trial was established to reduce the waste of kangaroo carcasses controlled by farmers to reduce grazing pressure. The evaluation of that trial found that the average number of kangaroos controlled was at least 2 times larger than the areas outside the trial areas and 2.5 times larger than the long-term average. It was clear that providing a financial benefit for kangaroo carcasses increased the numbers harvested regardless of whether unrelated to the purpose for which kangaroos were being controlled, which is to reduce grazing pressure. So it's highly likely, given the amount of biomass they need is 3 times the amount that the invasive native species right now could provide, and that we have this precedent related to the kangaroo pet food trial, that we're going to incentivise additional land clearing by farmers. This all assumes, of course, as well, that invasive native species are some kind of waste from a biodiversity perspective. But keep in mind that an understanding of whether these species are reaching unnatural densities and dominating an area would actually require someone to undertake an inspection and have an understanding of the ecology of an area. And we know that because there isn't formal assessment under the Native Vegetation Code, that this isn't happening. It's at the discretion, essentially, of the farmer to make those judgments. And given that there are 45 species listed as invasive native species, it seems unlikely that you can apply these blanket rules and be confident that you're not having a negative biodiversity impact. So I want to restate that if Redbank is approved, there is a significant risk that native vegetation clearing will substantially increase to meet the demand for biomass, leading to very poor outcomes for biodiversity. Thank you.
Okay, our next speaker is Professor Hugh Possingham. I want to just disclose that I have worked at the same institution for a long period of time, so know Professor Possingham well. Hugh, over to you.
Thanks a lot. Thanks a lot. Yes, I should be reasonably brief. I'm really going to talk about the issue of provision of fuel stock from the 4 main sources for the power station, invasive native species mainly, but also plantations, crop residue, and legal land clearing. And I want to talk about some of the major assumptions that I think are implicit in this document, or the documents that I read, and the fact that I think a lot of those assumptions are contestable and need to be actually provided. We need some more scientific evidence around those assumptions. One of the assumptions, and that's implicit in some of what I read in one of the videos, is that for invasive native species, those woody lots have no biodiversity value. That assumption is false. That's categorically false. There are many, many species that favour dense shrublands. For example, spotted bowerbirds, a whole heap of small bushland birds. So to say that they are of very low value is false. And we would need evidence that they are of no value, when most of my understanding is that they have them. Now, open woodlands, which are when you clear and manage those invasive native species, are also important habitat. I'm not saying they're not possibly equally important. But, you know, if they're very open woodlands with, say, a tree every hectare, they're probably not as useful to biodiversity. So this leads to the next point. So first of all, one, they are not of no value. They have actually some substantial biodiversity values. The second one is then that they are natural. So the narrative is, and this has been a common narrative around thickening in Queensland and New South Wales, that they're unnatural. Well, I agree that if you overgraze and you do poor fire management, which has happened in many of those systems, so it is something that Western agriculture has created, does change the vegetation and can tend to cause dense woody shrublands because of that poor management. But dense woody shrublands were certainly part of all those ecosystems in the past across central and western New South Wales. There were patches of dense woody shrublands everywhere and probably quite extensive areas. So they're not an unnatural ecosystem. They may have expanded in abundance in certain places. And the narrative that the early settlers said, oh, they drove their horses and carts through these lovely grassy woodlands, they were almost certainly, we have very scattered evidence, of course, they were almost certainly following Aboriginal songlines, which now become stock routes, which are the most productive parts of the ecosystems, which are heavily managed by the First Nations people using fire, and that maintain those open grassy woodlands. So that's an important point. So that's all the invasive native species stuff. When we're talking about the issue of plantations for producing fuel stock and crop residue, the first thing we really need to think about is that possible forever without degrading soil properties and removing nutrients? And that to me seems quite unlikely. So you need to prove that you continually take off this biomass and not actually degrade the soils, because if it wasn't taken off, it would go into those soils and you would have carbon and nutrients recycled into the soils. And on the biofuel side, and I have written papers on biofuels of various kinds, it is almost never an efficient land use. It is extremely unlikely to be profitable. So I'm very sceptical that biofuel plantations are ever going to create a consistent supply, because they're just so unprofitable when you include all the costs of haulage and all those other things and management. And that's true for biofuels around the world. I mean, I think they've played an important role in the transition, but in the end, I think they're not a great use of land, and of course, definitely not a great use of land relative to other agricultural uses. And then finally, the other assumption is that these things, that creating a demand for biofuels wouldn't affect legal and illegal land clearing. And there's a real worry that, in fact, having these markets, and markets are very difficult to control when you create them, you won't have these perverse outcomes in terms of legal and illegal clearing. So there's still 6 major assumptions, I think, implicit in these documents. And I think all of them need an evidence base, and they need to be sort of supported by scientific evidence for this sort of project to proceed. That's me.
Okay, thank you, Hugh. Our next speaker is Hannah Thomas.
Thank you. My name is Hannah Thomas, and I am a PhD researcher at the University of Queensland's School of the Environment and the Centre for Biodiversity and Conservation Science. My PhD research has focused on vegetation management and policy in Australia. Today, I'd like to chat for a few minutes about one piece of research in particular, where I looked at the value that regrowing forest and woodland ecosystems, which I will refer to as regrowth vegetation, often referred to as INS in relation to Redbank Power Station, provides for threatened species. My research occurred in Queensland, but many of the species I looked at also occur in New South Wales, and thus the results are still applicable. The most important takeaway from my research is that many threatened species can use regrowth vegetation as habitat, even when the regrowth is quite young. And here I will dive into a couple of the most important details. So first, we questioned 50 experts on the minimum age at which threatened species could use regrowth vegetation. The average age for all the threatened species that I examined was 15 years. The youngest, for a bird called the squatter pigeon, was just 3 years of age. Iconic species like the koala, who everyone is familiar with, could benefit from regrowth as young as 9 years of age. The age at which species can use regrowth depends on what they eat, how they move through the landscape, and the requirements for breeding and shelter. Of course, some species, such as the greater glider, need much older forests. This is because they require large tree hollows to shelter in during the day and large trees to feed on and move between at night. So young regrowth shouldn't be seen as an alternative to protecting older remnant forests. We need both. Second, we also estimated the proportion of each species' current habitat that comprises regrowth using satellite data and publicly available data. On average, it was 18%, but for some species, so the swift parrot and the regent honeyeater, regrowth actually made up about a third of their potential habitat in Queensland. Both of these species are listed as critically endangered and also occur in New South Wales. So what this means is that for threatened species living in landscapes where much of the remnant vegetation has already been cleared, regrowth is providing valuable habitat, resources such as food, and allowing easier movement between remnant patches of bushland. Finally, we looked at habitat loss. So around 3/4 of threatened species habitat loss in Queensland since 2018 was regrowth forests and woodlands. So while the loss of older remnant vegetation is more damaging per unit area, regrowth habitat is being lost on a much bigger scale. To summarize, our results show the importance of retaining as much regrowth vegetation as possible to benefit threatened species. The important context here is that so much of our original remnant forests have been lost for agriculture, housing, mining, renewable energy, etc., and populations of threatened species have been declining for many decades. We already have research in Australia that has shown that habitat loss is the #1 threat affecting threatened species and the most important conservation action. We should therefore be focusing on avoiding and minimizing all further threatened species habitat loss. The scoping report of the Redbank Power Station states in the introduction that Redbank will be fueled by ecologically sustainable biomass. I think there's very little evidence from my research and many others that clearing of regrowth is currently ecologically sustainable for threatened species. Thank you.
Great. Thank you very much, Anna.